Let's begin by saying something that we are all most likely thinking these days. We live in an era in which it's easy to feel a little overwhelmed by technology and innovation. Yet, if we look closely, humanity has evolved in step with the new tools it has imagined, designed, and created. Think of the first rudimentary knife made from a sharpened stone, or how flint was first discovered to produce fire, or the simple, maybe not so simple, invention of language. Even art and culture are, in some way, children of ingenuity. Take the painting era of Impressionism, for example. If someone had not invented small metal tubes to help bring color pigments outdoors, perhaps artists would never have left their studios to paint those landscapes and spectacular scenes. Ingenuity and creativity are strongly connected because when they come together, they allow us to look at things from new perspectives and try to find solutions that no one without them would ever have imagined. This has happened often in the history of Saipem, an aspect that struck Primo Levi, who, as you may remember, was a guest reporter on the Saipem pipe-laying ship in the 1980s. During his experience aboard the Castoro 6, the crew shared some interesting stories with him, which he wrote about in Eni's in-house magazine called Ecos. And I want to tell you about one in particular. First, it's important to know that one of the fundamental steps laying a pipeline is the process of welding pipe sections together. Back in the 80s, to make sure that they were sealed properly, they used a device called a pig, which was lowered into the pipe to take a type of X-ray. Then one day, the cable holding the pig broke. It fell about 300 meters deep into the pipe. The technical crew quickly got together and began thinking up ideas on how to recover it. The most picturesque idea, as Primo Levi called it, was to call the Tunisian operations office and have them insert a rubber ball at their end of the pipe and then pump in compressed air to push the ball until it reached the pig and then continue pumping the pig right out. So while they discussed the chances of this plan's success, another member of the crew, a former fisherman, came forward with another idea. Perhaps due to professional bias, he was convinced that the only solution was to fish the pig out. He claimed it would be simple and cheap, and that the workshop crew could build a sort of gigantic fishing hook. And just a note here, it was said that every minute of work lost by Castoro 6 cost, at the time, 280,000 lire. This, of course, was before the arrival of the euro currency. Therefore, it was worth spending a few thousand immediately to test the ex-fisherman's intuition. And it turned out to be the right choice. Once ready, the hook was tied to a weight and lowered down the pipe. In a few minutes, and with a lot of patience, the crew managed to reach and hook the precious pig, the X-ray machine, and hoisted it out of the pipe. A seemingly simple but very ingenious idea solved a major problem and allowed the crew to proceed with their installation. I'm Michael Los, and this is Ingenuity, a podcast by Cora Media in collaboration with Saipem. A journey through the projects, technologies, and engineering solutions of a company moving towards the important goal of shaping a sustainable future. If you don't want to miss the next episodes of this series, click the follow button. And be sure to activate the bell notification. And we'd love it if you'd give us 5 stars on Spotify. When ingenuity and creativity meet technique, you can solve problems with simple solutions. But in the world of engineering and infrastructure, very complex problems can arise. Some even seem truly impossible to solve. So far in this journey, we have seen how complicated it is to work in critical environmental conditions. Maybe it's the presence of uneven seabeds or the remote and difficult-to-reach locations. These obstacles are faced one at a time. unless they all appear at the same time in the same project as it happened in this next story. Let's now go to the Caspian Sea, off the coast of Kazakhstan, where, in the year 2000, one of the largest oil fields of recent years was discovered, called Kashagan. It is no small feat to develop and build an oil transport network in this area. I asked Giulio Credali, Asset SURF Fleet Manager at Saipem, to tell me about the difficulties he and the team faced. He told me about the bad weather conditions that tested their limits and a never-seen-before engineering solution, a ship that divides in half. But let's start from the beginning with a description of the scene.
Basically, we are talking about a location where the oil wells were supposed to be drilled, 5-meter water depth. We're talking about 5-meter water depth, and the location is a closed location, so it's not easy to get there. So the location is not connected to the international waters. It's difficult to be reached, and the oil field is a natural reserve. There are unique species, biological species that are living there. Another important element is that the location is having a range temperature in winter of minus 35 degrees Celsius, and in summer a temperature of plus 40 degrees. So there is a big difference between the two, let's say, temperature, and the wind is also very strong and very variable, because you can have a strong wind, but if it's constant, you can play with the design of the field. But if the wind is turning 180 degrees, very sudden and also very often, is making the installation activities extremely difficult.
So, very shallow waters, extreme temperature ranges, unpredictable winds, difficult environmental conditions. In order to face these challenges, the engineers have no doubts. An innovative, dedicated fleet needs to be built specifically for this project. So they began designing the Castoro 12, and it became the new flagship. It measures more than 100 meters, about the length of a football field, and is about 30 meters wide. On board, in addition to the pipe-laying equipment, there's also a helipad, cabins for the crew, offices, and common areas. On paper, it's perfect, but there's a problem. It's too big. It's too big because the canal that connects the Don River to the Volga River, where the ship must pass, is less than 16 meters wide, and the passage under the bridges requires a height of less than 4 meters. Those who worked on the design of the Castoro 12 talk about the weeks of great excitement, with meetings at all hours, day and night, to come up with a solution that, this time, seems impossible to find. Suddenly, the idea comes. If it can't be designed smaller, then let's build a ship that can be divided into 2 parts. The concept's a bit like modular furniture. Each piece functions on its own, but can connect to others. Of course, the Castoro 12 is much more complex than a piece of furniture. It's crisscrossed by thousands of pipes, beams, electrical cables. Not easy to design 2 halves that can pass through the canal separately and then reconnect and function as one at their destination. And then there's the other complexity, the heliport.
The helideck has a standard diameter to allow helicopter to land, and it shall be higher to everything else, because obviously the helicopter should arrive and not being obstructed by cranes or other structural element. And we remember that we need to pass below the bridge to reach the Caspian. So the helideck has a standard diameter of around 20 meters. Therefore, what we do, we have decided, obviously, that the line cut should pass through the helideck. So basically, this means that once we arrive in the Caspian, we have to refit the helideck, re-weld it, and recertify the helideck. So that was another challenge on top of the other challenges.
I really don't think there are many ships in the world like Castoro 12, huge ships that can be split in two, then reassembled as needed. Since it was built in 2006, it's done this several times, and it rarely makes the news anymore. But Castoro 12 remains an impressionable example of how creativity and technique together can lead to one-of-a-kind solutions. Speaking of creativity, what would happen if each of us put a little bit of our own creativity at the service of bigger things? That's when it really makes a difference. Saipem has taken a small but big step in this direction in a rather particular sector, that of the production of urea, which is used as the most widespread nitrogen fertilizer in the world. If you're not a farmer or gardener, you may not have heard of urea, but you've probably seen it. Those small white spheres, just a few millimeters in diameter, that look like polystyrene. It's often used in cultivated fields or gardens because it improves the quality of the soil and helps plants grow. It may seem to be, but it's not at all a trivial substance because producing urea supports agriculture all around the world, therefore contributes to food security, one of the biggest challenges of our time. Saipem, for many years, has been one of the main players in the global production of urea. Their first patent for this technology dates back to 1962. That's back when, on the cultural timeline, the Rolling Stones had their first live performance at the Marquee Club in London, and the first driverless subway train was inaugurated in New York. Processing methods have been perfected since then, and today about 40% of the world's urea production is made with Saipem's proprietary technology. In recent months, Saipem engineers have been working on the Ceres project, which everyone calls the Perdaman, after the name of the client who commissioned it. We're talking about the construction of one of the largest urea plants in the world on the coast of Western Australia, and once fully operational, will produce more than 2.3 million tons of urea per year. The process is quite simple, at least in theory. I'll try to tell you about it. One starts with hydrocarbons as a raw material, and in this case, it's natural gas, from which hydrogen molecules are obtained. Hydrogen is then mixed with nitrogen, extracted from the air, to produce ammonia, which is the first key element of this recipe. The second key element is CO2, or carbon dioxide, and by combining ammonia and CO2, you get urea. It seems ordinary and kind of easy, right? So why am I telling you about it? Because the chemical process is truly extraordinary, thanks to Saipem technology. The processing of natural gas to obtain hydrogen generates carbon dioxide, but it's not released into the atmosphere. Instead, it's reintroduced into the production process and combines with the ammonia in a second phase to produce urea. This choice drastically reduces the CO2 emissions of this site. And there's more. By the year 2050, this plant will officially have zero emissions. Thanks to the foresight of the client, of course, and also to the ingenuity of those who develop these solutions, who know how to integrate multiple technologies like solar power, green hydrogen production, and CO2 capture. True teamwork that involved professionals around the world from India to Italy. This is perhaps one of the most fascinating aspects of ingenuity where Saipem expresses itself to the fullest. It knows no geographical, linguistic, nor cultural limits. Ingenuity is precisely a strength that overcomes limits. But what exactly is ingenuity? How does a new idea form in our mind? And what mechanisms are activated when we are in the midst of the creative process? I asked Nicola de Pisapia, Associate Professor of the Department of Psychology and Cognitive Sciences at the University of Trento. He told me that creativity not only involves multiple areas of our brain, but it's also contagious.
During creative thinking, our brain displays activities in a number of brain regions, but it's not just that these areas are active. It is important to understand that normally these brain regions and networks are not functioning together. But when we are creatively thinking, trying to find a solution in a creative way, we observe that these networks, they work together. They are correlated, they collaborate. In a group context, so when several individuals are trying to find a creative solution to a problem, such as in brainstorming, the brain, during these interactions, they try to synchronize each other. And when communication works, we can actually observe that there are synchronization between the brain activities of different people, which facilitates the collaborative ideation process. So the interaction of these networks creates a kind of fertile ground for creativity, where diverse ideas can be generated, shared, and refined together.
It truly is fascinating to enter the mind and mechanisms of creativity. It seems almost like science fiction, yet the processes de Pisapia talks about are happening in our brain continuously, dozens of times a day. And it doesn't matter if we are scientists, painters, mechanics, pastry chefs, or engineers. Each one of us is naturally predisposed to creative thinking. Our brain is a fantastic biological machine, so it's not surprising that the most advanced technologies, from robotics to artificial intelligence, try to emulate the brain's mechanisms.
The interaction between analytical thinking and this more lateral thinking is crucial for innovative solutions, but not just in the creative context, in the sense of artistic context. On the contrary, it is crucial in all contexts in which we need to think to new solutions. So this is valid also in science, or in technical thinking, in mathematical thinking, but also in everyday thinking. So in every situation in which we need to find new and good solutions that we have never implemented before, we need this collaboration between analytical thinking and lateral thinking. So we can talk of a kind of a general creative process, independent of the specific sector, which can be applied to humans in every context, but also to computers. Think about generative artificial intelligence. So in these systems, we can say that the creative process is implemented.
Okay, so machines are not only learning to reason like us, but also learning to replicate the processes that drive ingenuity and creativity. When we talk about artificial intelligence, or any system that reproduces human behavior, it makes some of us think of past science fiction stories, which frequently pitted humans and machines against each other. I, on the other hand, prefer to think of a different, much more current story plot: robots as our indispensable allies. If these technologies are used well, not only do they simplify life and work, but they can even contribute to our collective well-being. Imagine a robot that allows you to do difficult tasks in complete safety, improves efficiency, and safeguards your health. Well, that's precisely the type of robotics that I want to talk to you about. We began this episode aboard the Castoro 12, an extraordinary ship. Then we returned to dry land in Australia to discover one of the most cutting-edge fertilizer production plants. Now it's time to go underwater, many meters deep, together with robots. That's right, Saipem also deals with underwater robotics. It does so through its Center of Excellence for the Development of Sea Operational Technologies called SONSUB. This is where ROVs were born, an acronym that stands for Remotely Operated Vehicles. ROVs are capable of underwater inspection of pipes and various devices and perform maintenance work on seabed infrastructures. The very first models, developed by Saipem a few decades ago, were wire-guided. Remember those toy cars, the ones that had a cable connected to a remote control box? Well, the traditional ROVs worked pretty much like that, but its cable, called the umbilical, was made of steel and was thousands of meters long. Using it, however, was not so simple. It had to be loaded onto a ship, lowered into the water at the point to be inspected, and then brought back to dry land. The system was certainly effective, but a bit cumbersome, so the technicians back at Sansub, a big group of men and women, rolled up their sleeves and designed something new, something different. Their challenge was to find a more agile, more efficient solution. And they did, once again with ingenuity. To come up with an idea that avoids the mobilization of a ship and an entire crew every time the ROVs were employed would bring huge advantages. It would reduce time and costs. A ship that stays in port has a lower carbon footprint than a ship in motion. And a team working on land is safer than a team out in the middle of the sea. So the technicians got to work. And in 2015, what De Pisapia was telling us before happens. Their minds begin to work in unison, sharing ideas and new insights. And they came up with a Hydrone program, a fleet of underwater drones capable of diving to about 3,000 meters deep without any cable connection. Not only that, they can also travel autonomously up to 100 kilometers and remain at the bottom of the sea for up to 12 months, and can then be awakened when needed. Perhaps you skeptics out there are wondering what's so special about this technology when today any device can be controlled wirelessly, even your air conditioner at home. True, but doing it underwater is a whole nother thing. To explain this, the Sansub engineers gave me a very compelling example. Imagine being in a completely dark room, closed, isolated with no reference points. How do you communicate with the outside world? An underwater drone is in exactly the same situation. But unlike us, lost in the darkness of our room, the Saipem drone is equipped with artificial intelligence technology. We're talking about a very sophisticated optical and acoustic communication system which exchanges information through flashes of light and sound waves, like sort of an underwater Morse code. It kind of reminds you of something, right? The animal world is often a great source of inspiration for engineering, and in fact, this mechanism is very similar to the ones used by whales, dolphins, and other aquatic mammals to communicate with each other. Hydrone truly represents the latest frontier of underwater robotics, a technology that is already making a difference even in extremely difficult environmental conditions. Let's talk about the case of the Njord field, an oil and gas reservoir off the coast of Norway. Here, Saipem is providing underwater services with the first underwater intervention drone in the history of the industry. Its name is Hydrone R, and looking at it, it's almost like a character from an animated film. Its shape is a three-dimensional rectangular box, about 3 meters long, painted bright yellow, with cables and mechanical arms sprouting from its sides. But it has some very serious tasks, like improving the integrity and safety of underwater systems, collecting valuable information on the pipeline's condition, and intervening where necessary. From the control center on land, the pilots communicate with a submerged drone by uploading its mission, an algorithm, into the system. For example, if it's to inspect a suspended pipeline on the seabed, the uploaded algorithm will autonomously direct the drone. It can decide to slow down at a specific point to better control, or stop and send data and images to its pilots. Once the operation is finished, the drone goes to rest on the seabed and waits for the next mission. We're talking about an exceptional vehicle that, to this date, has been able to operate continuously for almost 6 months and has reached a milestone of being on the seabed for an uninterrupted 167 days. So, just imagine the potential of this technology. Sansub is already working on new ways to use underwater drones. For example, for monitoring water quality and investigating marine biodiversity. Dozens of ideas are coming to mind, but it's best to keep your imagination in check for now. Everything in its own time. Meanwhile, the fleet of ROVs and drones has been made available for the maintenance of the Green Stream gas pipeline. You may already know that this is a very important energy artery, more than 500 kilometers long, connecting Libya to Sicily. Saipem laid this pipeline in the early 2000s, and it's still the longest underwater line ever built in the Mediterranean. And more than 20 years later, Saipem is still involved in the project with a series of activities related to maintenance and management of emergency interventions. Here, too, the technologies are exceptional and innovative, such as the remote repair system called Circos, which is capable of working at a depth of 2,200 meters. The extraordinary thing is that it conducts emergency interventions. For example, it can repair a leak in an underwater pipeline in diverless mode. That is, no human divers. This guarantees not only greater safety during operations, but also an effective and immediate response in managing a crucial energy supply infrastructure for Italy. This was a fascinating episode. We talked about quite a variety of innovative solutions, from Castoro 12 to underwater drones, but they all have something in common. They were all created from the same energy, a special energy that we celebrate here. We can call it ingenuity, inspiration, the creative spark. How we label it is not so important. What matters is that this energy continues to flow and feeds the minds of those who every day develop cutting-edge technologies to face the unknown challenges of the future. Ingenuity is a podcast by Cora Media, produced in collaboration with Saipem. Written by Alessandra Menozzi. Translated and narrated by me, Michael Los. Editorial curation by Graziano Nanni. Sound and music supervision by Luca Micheli. Post-production and editing by Aurora Ricci. The project manager is Anna Nenna. The producer is Alex Peverengo. The post-production coordinator is Matteo Scelsa. The studio sound engineers are Luca Possi and Lucrezia Marcelli.